Today, I wanted to talk about some angle rules that can be observed when you have a set of parallel lines intersected by another line. So today we're going to talk about some terms and what they mean necessarily and what you should know if you have a test upcoming for this. So when it comes to geometry, what you'll need to know ahead of this unit right here is line types. Probably that's pretty important, although not necessary. But parallel lines is a very important concept for angle rules. So the first relationship we can look at is interior and exterior alternating angles, which sounds like a lot at first, but I'll draw it out so it kind of makes a little more sense. So let's say that we had these two angles right here. These we would classify as alternating interior angles. So let's break it up a little bit. We can see alternating because they're on different sides of this intersecting line. So we have our two parallel lines in red here. And we have an intersecting line, which is the black line, that goes through both of them. Important detail is that these two red lines are parallel. That needs to be happening for this to even exist in the first place. Otherwise, this relationship just isn't true necessarily. So we can look at this. They're alternating, so they're on different sides of the line. And they're interior, which means they fall in between the parallel lines right here. So we can kind of break it up as some terminology, and that's how we get it. And now what we're going to say for this is, let's just say this is about, 65 degrees right here. If we know that this angle is 65 degrees, these two are parallel lines, and there's a line intersecting both of them, that the alternating interior angle will also be 65 degrees. So all that's saying is the two angles you have here will be equal. And now alternating exterior angles are quite similar. We have the same conditions that we have a set of parallel lines being intersected by another line. We're going to use this in the entire unit today because that's what needs to be happening. But instead of happening on the interior, it's going to be happening on the exterior. So we can look here. So these would be alternating exterior angles. Alternating because they're on different sides of the line. Exterior because they fall outside our parallel lines. It's the same idea, same concept. These two angles will be the same measurement. So let's say these are 50. This definitely is not the scale, and I did not measure it. But let's say this angle is 50 degrees. We can also say this angle is 50 degrees. So it's just an equal relationship, nothing more than that. Now we can look at allied angles. So allied angles can happen all over, but the general idea is that when it comes to allied angles, they will add up to 180 degrees because they are something that's called supplementary. And all that means is that, so we got two angles, x and y, they equal 180 degrees when added together. That's nothing more than that. That's all supplementary means. So in terms of the graph, we could draw that, let's say this one and that one. So when you have a set of parallel lines intersected by a line, you're basically going to have two angles showing up throughout. You're going to have a small angle and a large angle. I say small and large because they're relative. They're probably going to be one small, one large. Unless you have this directly going perpendicular, then everything's just going to be 90 degrees. But let's say this one is, 60 degrees. Using the allied rule, we can say that 60 here we've been given. So we know the remaining angle is going to be 120 degrees. Now, how did I come to that conclusion? We know that when it comes to allied angles, they're going to sum up to 180 degrees. So we have 180 degrees here. We were given 60 degrees. Subtract that. We have 120 degrees remaining. So when it comes to allied angles, you're going to have one that's given to you. And then you can find the other one by knowing that's the difference to 180 degrees. Now in corresponding angles, it's kind of similar if we went back up to alternating interior and exterior. However, it is slightly different because it's not alternating. So you can think they might still both fall on the interior, exterior. But what you're probably going to see this relationship as is something like this. So they're going to fall on the same side, most likely. And let's say this is, 130 degrees. Again, not measured out, but say for simplicity's sake, it's 130 degrees. Then we are able to say that this angle right here is also 130 degrees. So these are the three rules they need to know. So this is an equal relationship here. So we got basically two equal relationships to look at. We got the alternating angles and the corresponding, and then we have a supplementary case here for allied angles. First one, alternating, we can see that it falls on two different sides of the intersecting line, and that they will be equal to each other, no matter what the degree is, as long as you have a set of parallel lines intersected by a line going through it. When we look at allied, we know these two angles are supplementary, and they will add up to 180 degrees. And this happens when there's a set of parallel lines with a line intersecting through them. And then corresponding is two angles that can be found to be the same measurement. So you could see it like this, where these ones are 130 each. Or, I mean, you might see something like this too. These would be classified as corresponding. So it's kind of observable relationships. It's just a way for us to talk about the angles. It really isn't anything more than that. But these are helpful rules that kind of allow us to work our way around and deduce some facts. So let's go through some practice here. Let's look at, this one will be an allied angle example. So if you remember what allied angles is, they sum up to 180 degrees. Let's say we were given this angle, and we know it's 110. These lines are parallel, there's a line intersecting through it. And then your instructor wants to know what this angle is right here. How can we figure that out? Well, we can see that we got a set of parallel lines that are being intersected by a line. And using the allied angle relationship, we know that the angle we were giving, 110 degrees, and the mystery angle will sum up to 180. So we can take 180 degrees minus 110 degrees. And the remaining angle will be 70 degrees, which will be right here. Now let's look at another one. We can take this situation. I'll let you guys think of the property name before we actually observe it. Let's say your instructor was given this angle and it is, let's say, I don't know, 70 degrees or something like that. Now you have a set of parallel lines that are being intersected by a line. Let's give you guys a minute just to think about the relationship here. If you set alternating interior, that is correct. And we can observe that because we know it's interior because it falls in between the parallel lines. And it's alternating because the angles are on opposite sides of the line. Now what does that mean? That means that this angle right here will be the same angle as this one. It's an equal relationship. Now let's take another look at an example here. Say we were given these two angles, all assumptions fall the same. We got a set of parallel lines intersected by another line. Let's say this is like 65 degrees here. I guess 66 because I drew that 5 poorly. What will this angle be here? Now if you said 66 degrees, that is correct. And this is a corresponding angle relationship. And we know that because it is an equal angle relationship that does not fall in the alternating interior or exterior category. Now let's look at something a little different. This is going to be a deduction problem. You're not necessarily going to have a direct rule. But let's say we were given this angle. We know it's 60 degrees. We know that these two red lines are parallel and they're intersected by a black line. Okay? Now your teacher wants you to find this angle. It might seem a little confusing at first, but there's a couple of things we can look at. We know that the sum of two angles on a straight line are going to equal 180, so you could look at these as supplementary angles and go that route. I mean, you could look at this one would be 60 degrees because of alternating angles right here. And then you could figure out these add up to 360 when you put all this together. But I would say the easiest way would just to be looking at this. And you know that the sum of two angles on a straight line have to equal 180 degrees. So you take 180 degrees minus 60 degrees, and you get 120 degrees for this missing angle right here. Yeah, let's see another example that might require a little bit of solution. Let's see, we got an 8, okay, definitely not an 80 degree. Let's say 115 degrees or so. Again, probably not correct. Not measuring out these angles, Say your teacher wanted you to figure out this angle right here. You weren't given. We actually do have a property that you could just use to figure this out. Give you a second to think about it, just to look at the graph, try to understand it, talk about the properties that we discussed earlier. If you said alternating exterior, that would be the correct answer. And since this is an equal relationship, we know that this mystery angle that we're not given is 115 degrees as well. So, reminder that alternating exterior, you have a set of parallel lines intersected by a line causing the alternating exterior angles to be equal. So now I wanted to give a situation where we had a set of parallel lines intersected by another set of parallel lines, which might be kind of confusing at first if you definitely see it. But I kind of want to talk about ways we can work around knowing these properties. So let's say we know that this one is 130 degrees right here. Just put that number out there. We could use alternating angles to say this one is also 130 right here. We could use the 180 angle rule, knowing that this one right here is 50 degrees. And then we could say that these two angles are equal here, which means this one would have to be 50 degrees again. You can move this one 50 degrees, which means this one's 130 degrees. I just kind of wanted to show you guys a general idea of it, that when you know these rules, you can work around in this exact situation quite easily. I mean, we can look here, we have 130 degrees. We know that this will be 130 degrees. This one has to be 50 degrees. And we can just keep moving along as we go, figuring out these mystery angles based on the rules that we just discussed. Now, interesting enough, the shape in the middle is actually a parallelogram. And that happens because these two lines are also sets of parallels. So that's just an interesting fact that you can deduce from this table. But to go over everything again, let's just do a little review. We have alternating interior and exterior. Break the name down, you can figure out where that rule applies. It's an equal relationship, so you can figure out that the angles are just the same. You have an allied relationship, a set of two angles that will be adding up to 180 degrees. You have a corresponding relationship, which is just an equal relationship. You can find it on the same side of the angle, and they'll just be the same degree. And then we went through some practice, which I'll leave on the screen. Slowly go through this. Feel free to pause if you need to look at any of these. But generally, that's all you need to know when it comes to parallel lines, angles, and the relationships that come from that. Beyond that, leave any questions in the comments. I'll be glad to answer and help. Share the video with your teacher. I'll be glad to speak to your class. But I hope you all enjoy the video and looking forward to teaching more. Take care.